Hello, everyone. Thanks for joining. I'm Chaitanya Bhatt. I'm a principal engineer at Intuit. I work in the reliability and operational excellence group. So today we're going to be talking how we democratize load testing at Intuit, from a specialist-only function and turned it into a company-wide capability. So if you're building a platform, a SaaS product, or a distributed system with real customers at scale, this talk is meant for you. A little bit of a background about me. I have worked in the tech industry for 18 years. I've been with Intuit for over 13 years. At Intuit, my primary focus is keeping our systems running smoothly during peak. I work in the platform group, so we build off a lot of reusable tools and platforms for rest of the engineers. So when I say platform, it's developer platform. My daily work revolves around managing Kubernetes controllers, observability pipelines, disaster recovery, operational data lake, etc. And I'm super excited today to show you how we applied the reliability mindset to complete democratization of load tests at Intuit. We got a packed agenda. I'm going to be talking a little bit about Intuit, Intuit's values, because these are really the driving or forcing functions, so to speak, for why we chose the approach we did. And then we're going to talk about why we picked Gatling. What were the requirements and how did Gatling serve these requirements? And then using Gatling, how did we end up building a platform on top of platform. And lastly, we're going to be talking about outcomes and a few takeaways and some lessons learned in the process. All right. So Intuit, I'm sure a lot of people would have heard our company, but I'm pretty sure a lot more people would have heard about the products that we make, like TurboTax, Credit Karma, QuickBooks, and MailChimp. These are extremely popular products. We serve over 100 million customers in many, many countries, not just United States. And we are sort of the operating system for small businesses. And during tax season, we are kind of the operating system for consumers as well, to do their tax returns. And this is a very, very critical part of a lot of consumers, in their financial lives. We play a very critical role. And when we are operating at the scale that we operate to serve 100 million plus customers, we have to take our job really very seriously, because any sort of an outage means, you're potentially disrupting someone's livelihood, especially on the small business side. An outage might mean, the payrolls are not going through, or the payments are not going through, or you're not able to look at your expenses, your business expenses, etc. And so really hurts the businesses, especially because we have so many businesses, millions of businesses counting on our platform. So we have no choice. And so reliability is not an option. It's a feature in our product, and we take it really seriously. These are some numbers and some of the features that I spoke about, like time tracking, payroll, cash management, etc. The sheer volume of transactions that we serve, to process $105 billion worth of tax refunds. You can imagine this, the transaction rate, and $2 trillion worth of invoice management. I mean, $2 trillion is a significant part of the GDP of the United States. So scale is quite overwhelming, but we've solved it. And to do all these things, right, to operate at the scale, we have rolled out an amazing infrastructure. We have automated a whole bunch of stuff, like the standard workflows for creating, your Kubernetes infrastructure. Like you want namespaces, pods, deployments. All of these things are automated in our developer workflows. So we don't have specialist teams for this. Most of it is self-service. And so we've taken the same principles and we've applied it to non-functional requirements like load testing as well. So those are the forcing functions, the culture that we have, the customer obsession that we have, the sheer amount of scale. And then we spoke about, business transactions, and we spoke about the culture of actually creating platform for everything, because again, it's if your test has to be driven from a platform, of course the infrastructure itself has to be driven through a platform. So we have a platform to manage infrastructure, we have a platform to test the infrastructure as well. So platform mindset was inevitable, and so we really had to chase that. Before we actually go into the nitty-gritties of how we built the platform, let's understand the basics. Why do we have to load tests? Yes, there is the scale problem, but how does that matter? So for those who are not on a day-to-day basis, like in the business of load testing, if you don't load test something, you don't know how your system is going to behave during peak period. So you don't understand the system resource utilization, what are your saturation points. If your availability is going to be compromised, you have no idea, what percentage of your availability is going to go down, and you wouldn't know how to prevent these things. So load testing is one way through which you figure this out. You can load tests in lower environment, but then in certain cases when your infrastructure is so complicated to set up, maybe having the exact replica of what you have in prod and pre-prod might be hard. So it's okay to sometimes load test in production as well, depending on how you strategize it, how you prevent customers from being impacted. Maybe you have a secondary site where you can load test, for instance. So you could do a lot of those things, but not running load test is not an option. So that being the ground truth and the fact, so we had the intent. We knew we had to get to the platform mindset, but the initial approach was like, let's pick a tool and let's roll with it. But then the problem is that a platform is not truly a platform if it's not standardized. So we ended up with a lot of fragmentation. We ended up with people picking different products. There was no standards. There was no way through which we can consolidate best practices. And also, things were not observable. So we didn't know who were doing the right things or the wrong things, who were not running load tests at all, etc. Right? So, and plus, everything was harder, right? Like, because since there were no standards, pretty much a lot of teams were reinventing the wheel, and it was just slow and inconsistent and not desirable. All right, so then we figured, okay, let's standardize on a tool, right? And let's make sure it's generic enough. But what are the key parameters that's going to be helping us finalize this tool, right? So we wanted a tool that would, at minimum, scale to these needs, right? Like it should be able to run hundreds of load tests. It should be able to drive enormous amount of load. It should be able to spin up enormous amount of load generators, and we should be able to integrate with a lot of CI pipelines. And so we chose Gatling, and it was sort of inevitable that we would go after a Java-based tool. When we initially picked a tool that was XML-based, it was hell, because it was good as long as you could use the GUI, but then as the script became complex, the GUI was not helping, it was hurting. So then when we saw a JVM tool that was something that developers could just load up in their IDE, it was like a miracle. A lot of developers instantaneously kind of thought about load testing the right way. They didn't have to read a book or anything. The functions were quite declarative. The DSL was useful, was very expressive, and then they could use a lot of libraries that they had already written in Java because we are a Java shop, a lot of services that we've written are on top of Tomcat and Spring Boot and whatnot. So it was just like very intuitive for our engineers to pick up a Java-based product. And so Gatling being a tool that's written on JVM, and a lot of engineers love Kotlin. So again, since JVM offers many flavors of programming language, it becomes all the more desirable. Security is another piece. Gatling SaaS and Gatling Enterprise offers this amazing benefit where you don't really have to share any proprietary information like your scripts, your source code, your libraries. None of these things have to be exposed to them. You're only sharing latency and throughput numbers. These are test metrics, so not really something that is sensitive. And so you can draw a very strong perimeter on what you want to really share with them. And then the fact that it's open source helps a lot, because there are times when we were ahead of the curve, like in terms of technology adoption, and we were some of the early adopters for new protocols. So we built those extensions ourselves and we started using it. So we weren't like kind of thrown in the situation where we had to pick another tool just because certain protocols were not supported. And lastly, it's highly scalable, right? Like, so for the ones who've used Gatling, they know it is like, if you want to drive hundreds of thousands of transactions per second, it's not a hard thing to achieve in Gatling. You don't have to tune it. You don't have to call in an expert. Any developer, getting started would be able to kind of drive that kind of load at ease. All right. This slide is the heart of the story. Democratization as a platform capability. What is a platform? Essentially, like, you're kind of not reinventing the wheel. Gatling SaaS itself is a platform. It allows many people to run load tests on it. So it's sort of already a platform. Why did we have to build a platform on top of platform? So we had to solve a few things, which is that like our developers didn't have to worry about access management, and they didn't want to actually learn which libraries to use. There are like a lot of proprietary Intuit libraries that had to be embedded in every project. They didn't have to learn about all these things. So we saw a need, right, like to automate all of these things. So we kind of embedded a scaffold, a template in every service that was created. And we also we developed a feature where like all the existing projects could also onboard. So when they go through this onboarding flow, we went out to PR, and they would get like a performance test repository, created in their source code. And so it becomes a lot more easy for them to just start working on the payloads and the workload configuration, rather than actually thinking about, which version of Gatling should I use? Which plugin should I use? Which library? How do I do this? Where should I put this code? So we created a pattern for them. So the scaffolding is one of the big pieces. And then the integration and providing role-based access control is the second piece. And then lastly, the CI/CD integrations and some of the automations that happens, like onboarding repositories, etc., is an automation that we do on top of our platform. So it is in terms of higher level abstraction. So it's a platform on top of platform that we created. And these are the APIs. These are the Gatling SaaS APIs that Gatling Enterprise provides. And so we integrate this with our IDP, internal development portal. And so I'm going to show you in the next slide on how the bootstrapping actually happens. But having this rich set of APIs really help, like if you want to create simulations automatically. Let's say you're a company and you have like 10 flavors of load tests that every service has to run, like some spike test, load test, and endurance tests, stress test or whatever, right? Like you can create these sort of like template simulations for all the teams as part of like day zero or day one workflow generation. And then you can using the Teams API, you can set the right roles and permissions for these teams as well. And so, like, if they're analysts or contractors who only have to execute, tests, they shouldn't mutate resources. You can set those right level of access control for those users. And onboarding the users itself is automated. So there's no Jira ticket or ServiceNow ticket. And, hey, I want access to the system. You don't have to waste time doing all of that stuff. All the heavy lifting is done by the API integrations between IDP and Gatling SaaS. So this is the IDP page that I was talking about where our developers interact. So this is the service catalog. They would go in and they would say, hey, this is an invoicing service, for instance, like, hey, these 4 environments, I want load testing in one of this environment. And when they pick that environment and they click the button, we bootstrap all the scaffolding that I just mentioned, the CI/CD pipeline, etc. And all that they have to do from there on is to look at the PR, merge the PR, and then start extending the scaffold that we've generated. This is how the pull request looks. They don't have to, as I said, they don't have to worry about the library version of Gatling or the plugin version. All of those things are pre-generated, and we manage it. So we have Renovate and other ways through which we can manage the versions of the library. So as months and years go by, things are going to be obsolete. So the users don't have to worry about, am I keeping this up to date? We do it for them. And then there are also, in this whole bootstrapping process, we've put certain elements in various automations that sends beacons out, it sends metrics out that we can later use to observe who's doing the right thing versus wrong things. And we can actually proactively reach out or fix it for them rather than they having to get stuck or continue to do the wrong things or be in the wrong path. As platform operators, we can actually solve problems transparently. So this is an example of how a repository looks. So it's super easy. It's hard to miss a performance test when performance test is embedded in every service. Any service repository at Intuit, if you open it, you're going to find a performance test folder. And so the companies that are struggling to see load test adoption, I would say, try this. It really works. At least we've seen it work. And this is the same for the CI/CD pipelines as well. So if your build pipelines also has a performance test pipeline, everything is integrated for you. You don't have to do much. So the barrier for entry is low. So teams are going to be more encouraged to do the right thing. So this is the CI/CD pipeline. This is the part where you can put anything related to load tests. Like here we've put like execution of the load test and the load test analysis. So the script in itself, one of the beauty of Gatling is that it actually does assertion of the client-side metrics. But if you want to do analysis of the server-side metric, you've got to build it yourself. So we've done that. So this is a Jenkins pipeline. It triggers the load test, and Gatling test it in itself passes or fails depending on whether the throughput assertions, the latency assertions are passing or failing within the script. But then if, let's say, everything passes on the client side, but then on the server side, you are burning more CPU or you had more pods or your load balancer was thrashing, you can still fail the test and say, like something is off with this infrastructure. I think we rolled out something that's messing up the infrastructure, and you can block the build. So this is sort of like a blueprint of how our CI pipelines look. We prepare it along with integration tests and security tests. You can run it in parallel. I would recommend that you run performance tests in parallel, and because generally performance tests are going to be running longer. So we recommend a 10-minute test as a smoke test in the pipeline, but then a daily or a nightly job, or let's say that you are releasing with a cadence of 15 days or whatever. So you can pick the frequency and then and run scheduled jobs for services, and then always have the CI test because it ensures that you're not missing tests. Especially if let's say you're releasing 2 builds on the same day. You don't want one of the builds to be released without a smoke test. This is a simulation catalog that I was talking about. Again, the engineers who are new to this, they don't have to really learn everything about how to create a simulation. How do I pair a simulation with a repository? This is an example of how our team structures look. There are thousands of teams. As an admin, I can see all of them, but 3,000 plus engineers are onboarded, and they're mapped precisely to the team they should be mapped. And all of it is done automatically. This is the repository configuration. So when teams are, if you leave the engineers to set up repositories, they're gonna use their GitHub tokens and etc. Just gonna create a lot of mess. Again, using the APIs, you can create service tokens that have expiration that frequently expires. Like maybe you set it up like weekly expiration or monthly expiration, and then you rotate the tokens. Because you're the platform operator, you have the power to do it. If you let the users create repositories, they're going to use personal tokens, and they're going to expose it. They're going to create security nightmares. So don't do that. Use the APIs, manage the tokens, and rotate the tokens, and keep your systems very secure that way. This is the real-time simulation results. This is one of the most appealing features for me. I mean, if I'm running performance tests, I want to know what's going on. Right? If something is breaking in production, I don't want to wait for an hour impacting all my real customers. I want to abort the test right away. And so with a real-time simulation, you get to know immediately when something is off. If the latency is going up, or the throughput, or the error rate is messed up, you are able to react very quickly. If there are issues on the network side between the load generator and the service ingress, like a load balancer, you'll be able to figure it out very quickly, because Gatling gives network data specific to each load generator and specific to each endpoint that you're hitting. So that's amazing. And you get the full matrix of every single transaction that you're hitting. So if there's a problem with an endpoint, let's say you have 15 endpoints involved in a load test, you'll be able to pinpoint if there is one endpoint that is having an issue very quickly, and you're going to get this matrix in real time. You don't have to wait for the test to complete. So this is the SLO report, and this is the way we configure it. This is, again, a proprietary information. Like, we have built this. We want to open source it one day, but this is something that we build. It's a YAML-based declarative way through which you say whether the service, server-side metric is good or bad. You kind of declare it, and then once the test completes, the Jenkins pipeline can validate the thresholds and can pass or fail the test. So this is the YAML construct where we define the criteria. What are we measuring? What is the aggregation function? Like, is it quantile? What quantile is it measuring? And what is the set threshold? And this is the report. So every test, in the CI pipeline, once the test completes, you're going to get this report. This is another great feature of Gatling, where if a test is failing because the load generator is saturated, let's say the JVM is having frequent garbage collection and it is causing spikes, it's very likely that it's going to cause skewness in your results. So you don't want to take that result and then make a decision. So you're going to quickly you're going to know very quickly when things are off on the client side. And I love this feature. And this is the observability piece of Gatling infrastructure itself. You kind of get APIs that allows you to export all of the usage data. So as and when teams are running tests, you kind of get information. And when there are cold teams that have not run any tests, you kind of very quickly know, because you have information about that as well. Who's running tests, who's not running tests, who has more broken tests, who's using how many load generators, who's driving how much load. All of that stuff is available at your fingertips. We do it in real time. And the fun part is we also do it through our data pipelines. We ingest this data to our data lake, and we have glue data catalogs and high meta stores where, depending on the flavor of data lake query that you want to run, you can either use high meta store to run your SQL and analyze information about your coverage, especially if you are a large business group and you want to know how many teams in your business group is not compliant. You can do those kind of analysis by exporting this data. I definitely want to cover this architecture slide because it talks a lot about how we wired up ADP with Gatling Enterprise. The boundaries that you see, the blue lines, is essentially a perimeter, and we don't exchange scripts, data. We don't exchange the source code libraries, nothing with Gatling Enterprise. So the control plane is located within our own VPC, our own company network, and nothing gets exposed or nothing is vulnerable. So that's a very tight boundary. And the box one that you see is our IDP. IDP talks to Gatling SaaS controller during the bootstrapping phase, where we bootstrap scripts, etc. On box 3, there are 2 boxes labeled box 3. We're talking a lot about the control plane and the load generators. We have different flavors of load generators. Certain class of load generators are outside of Kubernetes because the egress path that they take, don't go through the same transit gateway. So a great feature of Gatling is that you can have any varieties of load generators. So we have load generators that go through transit gateway. For the packets go through transit gateway. Certain class of load generators goes through internet gateway. Some certain classes of load generators have elastic IPS associated with it. And then you have classes of load generators that are very sort of beefy. They are huge systems that are meant for generating large amount of load. These are very expensive systems. We don't expose it to every team. We selectively expose it to certain teams. All right, so we're wrapping up, getting there. So we did all of this. So what improvements have we seen? Load test is democratized now. So performance test is integrated from day one in every service repository, and automated test runs happens continuously on key development events. So issues are caught very early on. We can also run chaos tests and failure mode tests through our APIs. We thought by creating a platform, you're just serving users who are interested in performance tests, but because we created a platform on top of a platform, now we have other NFRs, like non-functional requirements, that are integrating with performance test platform, like the chaos testing platform. So this shows the outcome. So this graph is showing how many services at Intuit have started utilizing Gatling. From 2019, where we did not have Gatling adopted as a platform tool, to now where it's a mainstay, we see a huge uptick. We run over 80,000 load tests annually. We have more than 1,400 services with perf test folder embedded, and these repositories are getting compiled by Gatling, and the load tests are executed in the Gatling platform. In terms of number of developers who are onboarded, we had less than 100 developers who were using Gatling in 2018 to now, or over 3,000 users have been onboarded. And there's a significantly reduced fragmentation. We don't ever hear, issues like, this team is using some other tool, they need help in this and that. The consolidation has helped us a lot in terms of streamlining and creating efficiency. All right, we are not done with this. One area is that we are working on is to fully automate the script. We haven't really closed the loop on scripting. We want to use MCPs to go ahead and analyze the source code and and kind of like probabilistically create a script that looks almost close to what the final state of the script is going to look like. Today, our scaffolds look a little raw and basic. It's not close. It's not close enough. So with AI, we want to close that loop. And so the burden on the engineers eventually should be very few things, just like analyzing reports, creating test data. Maybe these are the things that they work on. We also are going to be focusing on validating whether the effectiveness of the script is there yet. Like you could be testing with the right amount of API call distributions and throughput, but then if you're not sending the right payload, your scripts are not going to be as effective in reproducing production characteristics. So we are working on figuring out how to validate the effectiveness of load tests. All right, so what are the key takeaways? I would say empower developers, make it self-service with templates, and create simple RBACs, create great governance models. It's going to help in democratization. Like without having all these scaffoldings, without having performance tests and CI/CD pipelines integrated with performance tests, it's not going to be a muscle memory that developers are going to have. If you let them pick their own tool, it's again going to create a lot of, there are going to be few engineers who are going to be excited, they're going to bring something, but then to maintain it and to create a unified outcome as a company, it's going to be pretty hard. So once you have this muscle memory, once you have all this like continuous execution, you're going to have a culture of performance. Okay? And once you have that, don't stop there. Using these observability metrics, as I said, like, the utilization metrics of this platform, learn from it. Learn what is working well, what's not working well, and then iterate and improve the platform. That's pretty much our journey. I hope I shared a few learnings that could help you in your job and your company. Thank you so much. If you have to reach out to me, it's a QR code.